Like I said, you guys, I graded your quizzes. I'll put numbers on them this afternoon. I'll probably enter the grades in the morning and give them back tomorrow. You guys will have a 5-1 to 5-6 test. It's your last test for quarter 3 next Wednesday. So we're going to work this week on just practicing law of sines, law of cosines. I'll go over some things that you might have questions on from your 5.1 to 5.3 quiz. We're going to have some word problems that go along with this, that sort of a thing. So you guys will have plenty of practice time and preparation for your test, which is next Wednesday. As far as 5.5 and 5.6 go, it's the law of sines, law of cosines. There's formulas that go along with this. We're going to give you guys the formulas on the test, so you don't have to memorize everything. We use the law of sines when we're solving oblique triangles. Okay, we talked about oblique triangles last week, and we talked about the area and stuff. What kind of a triangle is this that I just drew? It's a right triangle. How do you know it's a right triangle? It's got that 90 degree in it. Okay, if you guys were asked to find different things about a right triangle, what's the theorem that you would use to find side lengths of a right triangle? A squared plus B squared equals C squared, right? Right, our Pythagorean theorem. If I knew that this angle right here was 27 degrees, I know that this one's 90, can I figure out what the other one would be? Yes, because we add them up and subtract from 180, because there's 180 degrees in a triangle. If you had an angle measure but needed a side length, you could use your trig functions, because you can use trig functions with our right triangles. In this case, you guys are dealing with oblique triangles, meaning there's no 90 degree angles. There's no right angles. So if you're given two angles and asked to solve the triangle, you can add those two together, subtract from 180, find the missing one, that sort of thing. Then we can find sine lengths. We're going to go through that. Okay. This just goes over different scenarios of how you could be given information. You can be given two sides and an angle, two angles and a side, two sides and an angle with the angle not included, that sort of thing. And we'll talk about more cases and scenarios today and tomorrow. But one thing I do impress upon you guys is you have to make sure, if there's not a picture, you draw one so you can get a visual. There's 3 options for what your answers could be. And we'll talk about this more tomorrow, something called the ambiguous case. But you can have 3 different kinds of answers. You could work a problem. You could get using the law of sines and come out with no triangle can be formed. That is a possibility. You can work using law of sines and find out that one triangle can be formed. And then you can find all the missing pieces, the sides and the angles that are missing. There's also a scenario where there's 2 triangles present. That's called the ambiguous case. Ambiguous case. When you're using the law of sines, you always have to check to see if there's 2 triangles. And the stuff we're doing today, it's either going to be one or none. But tomorrow we're going to do examples where there is a possibility of 2 triangles. So on your test, it's going to say, using the law of sines, we're going to give the law of sines, and then it'll say, solve the triangle. If there are 2 triangles, find all the pieces. So you always have to check for 2 triangles, okay? This is your law of sines. All it is a proportion. It's a proportion of the angle measure in regards to the side length, okay? If there's not a picture drawn, I suggest that you draw one. I draw my oblique triangles the exact same way every time, and I label them the same way every time. I put A here, I put B here, and I put C there. Notice that I labeled my angles with capital letters. Angle measures are capital letters, and they will have a degree sign with them. Now I'm going to use the word corresponding a lot. Corresponding sides and angles are across from each other. So side A is across from angle A. Side B is across from angle B. And side C is across from angle C. Do you guys see that? So some of you are going to say, well, I don't know how to label my triangle. It doesn't matter. As long as you keep angle B across from side B, it doesn't matter where you put them. As long as A is across from A, B is across from B, C is across from C. But in order to use the law of sines, you have to have an angle measure and its corresponding side. When it says use the law of sines, you will have enough information to use it. Okay, Very important. Another thing is you can write this the other way. You can write this with your side length on top and your angle measure on the bottom. That's fine. This is still the law of sines if you guys like to write it this way. It does not matter. Either way, just as long as your angles and your sides stay together. You can use angles on top, sides in the bottom, or vice versa. All right, you guys okay? Everybody with me? Okay, again, this is just what I just talked about. Do you guys see how angle measures are across from side lengths? Very important. And also, how many angles are there in a triangle? There's 3 angles. And how many sides are there? 3 sides. So there's a total of 6 quote-unquote answers for each triangle. You will be given 3 pieces of the information, so you're going to have to find the other 3. When it says solve, you need to know all the side lengths and all the angle measures. So it's not going to say find B, C, and angle B. It's going to say solve the triangle, and you guys need to find all the missing pieces. So make sure you understand that. This is obviously a word problem. We're going to get to word problems later on in the week. I didn't want to start off with a word problem, so we'll come back to your tracking a satellite because you got to draw a picture. We're going to go over these 3 examples at the top and then the 3 at the bottom. Some of them have pictures, some of them don't. If you notice, the directions say to find AC. We're going to find everything in the triangle. All right, let's talk about what we have, what we're missing, and what we need to find. All right, if I look at this first triangle, what's the information that they gave me? 2 what? They gave me 2 angles and one side. So you have to find all the stuff that's missing. So let's identify first the missing stuff. I have to find angle C, I have to find side B, and I have to find side A. Do you guys agree with that? Yes. Okay. First things first, figure out what you have and what you're missing. Figure out what you're looking for. Now, the easiest thing to solve for when you have 2 angles is always the third angle. How do I find out the missing angle when I already have 2 of them? I add and subtract. I say 118 plus 22 gives me what? 140? 140 degrees. So then I say, okay, well, 180 degrees minus 140 degrees gives me what? 40 degrees. So I know that angle C is 40 degrees. So you already know one part of your answer. Angle C is 40 degrees. Now this section is called law of sines. Using the law of sines. Law of sines means you have one angle measure and its corresponding side length. Do we have that, what I just highlighted? Do I have angle C and side C? Yes, so now I can use my law of sines. I can simply set the proportion, I'll do it up here, sine 40 over 24. Now you set that equal to another proportion. You have to find the other 2 side lengths. It doesn't matter, you have both angle measures, you can find either one you want to, it doesn't matter. What do you guys want to find first, B or A? B? Okay, so what's across from B, what angle? So sine 22 over B. Once you guys have this set up, you do the same thing every single time. I have a fraction equals to a fraction, so we do what? Cross multiply. I have 24 times the sine of 22. Don't do anything in your calculator till the very end. B times the sine of 40. I need to get B all by itself, correct? So divide both sides by the sine of 40. So what does B equal? Round it to the nearest tenth. In your calculator, what's 24 times the sine of 22 divided by sine 40? What'd y'all get? 13.98, something like that? So we'll just say 14.0. If you did not get that in your calculator, you need to say, hey, Mrs. Meadows, can you look at my calculator? Because you might be in the wrong mode, you might be just hitting the wrong buttons, but B is about 14 units, whatever it is. On your test, it'll say centimeters, meters, yards. You need to put your units. Yes, ma'am.
If it's in like centimeters, yards, do we have to put like square?
No, because you're not finding the area. You're just finding length. Good question. All right, so now I have to find side A. We're going to do the exact same thing. We're going to find it the exact same way. I'm going to go to the original proportion that they gave me. Sine of 40 over 24 equals sine of A is what? 118 over side A. So now we cross multiply. 24 times the sine of 118 equals A times the sine of 40. Divide both sides by the sine of 40. And in your calculator, what is A about? Like 32.96? So it's about 33.0. So A is about 33.0 units. So think about it this way, right? Think about our triangles. The biggest angle should be across from the longest what? Longest side. So look at what we found. 118, that's our biggest angle. Is 33 the longest side that we found? Yeah. Is 33 the longest side that we found? Yes. What's the smallest angle we have? B, right? So 22 is the smallest side? B? Yes. So this would be your answer right here. And again, tomorrow we're going to talk about something called the ambiguous case. That is when we have to check to see if there is a second triangle present. That cannot happen if they already give you two angles, but we'll talk about that a little more. All right, let's scoot along here. What do we have and what are we missing? What do we need to find? Let's highlight the three things that we need to find. I need to find angle A, right? I need to find side C, and I need to find side A. Does everyone agree with me? Okay. Do I already have a side measure and its corresponding angle? Yes or no? Yep. Don't I know all the information I need to know about B? I know the side length is 7, and I know the angle measure is 44. So I can go ahead and already set up my proportion. I can already say sine 44 over 7. That's what I'm going to use to solve the rest of my triangle. Now, some of you are going to say, what do I solve for first? Well, think about it. If you wanted to solve for A, do you know anything about side A or angle A? No, so you can't solve for that one. So you'd have to go for C first. So you would say sine of 53 over side C. I don't know what it is. Questions? Okay, so let's cross multiply. 7 times the sine of 53 equals C times the sine of 44, right? What do I do now? Divide both sides by sine 44. And in your calculators, guys, what is 7 times the sine of 53 divided by the sine of 44? About. It's 8.047. So it's about 8.0. Perfect. So I know that side C is about 8.0. So now we need to find both things about A. I need to find the angle measure and I need to find the side length. What's the easiest thing to look for first or to solve for? For A. The angle, right? Because I already know two of the angles. I already know 53 plus 44 is how much? What's 53 and 44? 97? 97. So then I take 180 minus 97 and I get what? I know that angle A is 83 degrees. So now I have everything I need to know. I'm going to use my proportion that they gave me at the beginning. Sine 44 over 7 equals sine 83 over A. I don't know how long A is. How do we do this? Again, we cross multiply. So 7 times the sine of 83 equals A times the sine of 44. Divide both sides by sine 44. And A equals about how much? About 10? 10.0. Okay, good. So we solved this triangle. We found the three missing pieces. We found the two sides that were missing and the angle. Yes, ma'am?
If you already know the two degrees at the bottom, why couldn't you start with A if
You could.
B?
You could.
Okay.
I just always go with whatever is given. But yeah, that's fine.
Okay.
Yeah, there's 100 different ways you can do this. Like this one. Like, personally, the first thing I would do is add those two together and subtract. I would say, okay, 58 plus 93 is how much? 58 plus 93. 151. And then 180 minus 151 gives me 29. So angle B is 29 degrees. I already figured that out. So now I need to find side C and I need to find side A. I already found angle B right there. So I know that the sine of 29 over 16 is what I can use. That's my law of sines. That's my proportion. That's going to help me find the other ones. So then I could just say sine 93 over A. Cross multiply. You get 16 times the sine of 93 equals A times the sine of 29. Divide both sides by sine 29. And A equals how much? 32.957. So about 33. Now I'm just rounding to the nearest tenth right now, depending upon what the directions say to do, you guys need to do. So I found out angle or side C. I found A. Let's find C. So I'm going to go back to sine 29 over 16. Could you use sine of 93 over 33? Absolutely. I'm just going to go back to what my original was. So equals sine of 58 over side C. Cross multiply 16 times the sine of 58 equals C times the sine of 29. And C is about how much? 27.987, so it's about 28. Perfect. All right, questions on those first three. We were given two angle measures. We had to find the third angle and the other two sides. Everybody okay? All right, these next three are a little different. They're a little different in a few different kinds of ways. So let's look at how they're different. First of all, what is noticeably different about this one? There's no triangle. If I were you, I would draw one. Again, you can draw your oblique triangle the exact same way every time, but sometimes it's just easier to see things if we can visualize it. So fill in the information they gave us. They told me that angle B was 73 degrees. They told me that side A was 7, so I'm going to put 7 across from angle A. And they told me that B was 5, so I'm going to put that across from B. Can I just add up two angle measures and figure out what the last one is? No. All right, we're looking for different information here. Again, tomorrow we're going to check to see if there's two triangles present. These are scenarios where two triangles could be present. If they give you two angles, you just add up and find the other one. In this case, you could have either no triangle, one triangle, or two. We're going to talk more about that tomorrow. I just want to get into the practice of doing this now. Do I have a law of sines proportion that I can start off with, though? Do I have a side length and its corresponding angle measure? Yes or no?
Yes.
Yes, I have sine of 73 over 5. Angle B over side B. So now you guys can find whatever you want. Can I just go ahead and find angle C? Yeah? Can I go ahead and find angle A? Can I find C? Do I know anything about C? I don't know its angle or its side. So I have to find A. So I'm going to put sine of A over 7. That's what we're looking for. So now we do the exact same thing. We're going to cross multiply. So 5 times the sine of A equals 7 times the sine of 73. Divide both sides by 5. And again, guys, this is a little bit different than our other one that we just did. Why is this a little different? How is this different? Okay, we're going to get a decimal because what are we looking for here? Are we looking for just A? No, we're looking for the sine of A. I want just the A value, but this is what I got when I did this. So there's a couple things that should go off in your mind here. This happens, guys, when you're looking for angles. Does it make sense that one of the angles given was 73 degrees and the other angle is 1.3 degrees? Does that make sense? No. Is my letter A here all by itself? No, that says the sine of A. Does anybody know what the opposite of the sine of A is? Look at your calculator. Anybody know what the opposite of sine A is? Sine -1. That's the inverse, right? You guys have always, you're like, well, how do I, because what, right? We're trying to get A by itself. We don't divide by sine. We have to do the inverse of sine. So what you do to one side of your equation, you have to do where? You have to do it to the other side. So this cancels out. This gives me A. So in your calculator, you guys need to hit second sine, so that little -1 comes up. And you need to put in at least 5 decimal places. Now, I'll show you a little shortcut here in a second on your calculator, but plug that in. Second sine. I think she's looking at me like, what? 1.33882266. And what do you guys get? What does your calculator say? Error. Did you put something in wrong? No. This is a case where no triangle exists. You can just say no triangle. The information they gave you is not equivalent or will not create a triangle. So when you plug that into your calculator and your calculator says error, it could be something you did, so you might want to redo it. But don't just automatically assume that you did something wrong. There is a possibility that you try and figure these out and your calculator says error because a triangle cannot be formed with the information that they gave you. All right? All right, let's go on. Let's look at this next one. I don't have a picture, so let's draw one real quick. Again, here's A, B, C. What's the measure of angle B? 117 degrees. They told me that, so I can fill it in. What else did they tell me? Side A is 16, so 16 goes over here across from A. And they told me that B is 38, so B goes across from here. So I am looking for angle C, I'm looking for angle A, and I'm looking for side C, correct? Do I have a proportion that I can use where I have an angle measure and its corresponding side length? Do I have that right here? I sure do. So I can say sine 117 divided by 38. Now again, guys, where do I have to go? Can I find C right now? No, because I don't know anything about the side or the angle measure. So I'm just going to say sine of A over 16. When I solve this in my calculator, I am not finding the measure of A. I'm finding the sine of A. So we have to do one extra thing. I have 38 times sine A equals 16 times the sine of 117. Divide both sides by 38. Now I want to show you something in your calculator. You get the sine of A equals, in your calculators, guys, do 16 times the sine of 117 divided by 38. And what do you guys get? 0.37516. Yes? All right, now don't do anything. In your calculator, hit the second button, and then sine. So a little sine -1 comes up. Then hit second. Hit second again. Hit second again. Did you do it? And then the answer button. It's on the negative sign down by equals. And then hit enter. What do you get? About 22 degrees. Okay. If you guys didn't catch that, I'll show you again. It's second sign, second answer. You can, from this point right here, manually plug that in your calculator. Second sign, 0.37516. But just so A, you don't make a mistake and rekeying stuff in, or B, you get more of an exact answer, just hit second sign and then second answer, and it'll bring back your latest answer. So we got here the angle A is about how much? 22 degrees, right? Well, if I know the angle A is 22 and B is 117, can I figure out what C is? Yeah. How? Add and subtract. 117 and 22 gives me what? 139. And then 180 minus 139 gives me 41. So angle C is 41 degrees. Good. And now can I figure out what side C is? Yeah. Yes, you can use either proportion you want to. I'm going to go back to the one that they gave me at the beginning, so I know it's the most accurate. So I'm going to say sine of 117 over 38 equals the sine of 41 over C. Now, I'm not going to have to use my second sine, second answer because I'm not finding an angle measure. I'm finding a side length. So cross multiply 38 times the sine of 41 equals C times the sine of 117. Divide both sides by sine of 117. And C is about how long? 27.979. So about 28.0. So on a test, can I give you guys like 15 of these problems to do? Yes or no? No, because they take too long. All right, for some of these, you're going to get to where you get 6 different answers because there's 2 triangles. You got to find 2 sides and an angle of both of them. There's a lot. But if you know what you're doing, it's not that hard. It's a little time consuming, a little bit. So here, let's find all the info we need. I have A, I have B, and I have C. All right, they told me the angle C is 145 degrees. That's a very big angle. They told me that side B is 7, so across from B is 7, and they told me that across from C is 33. So I am looking for angle A, I'm looking for angle B, and I'm looking for side A. So what's the first thing that I should write down? The absolute first thing I should write down is what? Sine what? Sine of 145 over 33. That's the given proportion. I know a side length and its corresponding angle measure. So am I going to find now the angle B or am I going to find angle A? I got to go for B because I don't know anything about A. Guys, I'm finding the sine of B. I'm not finding the actual measure. This is where I have to go second sine in my calculator. So cross multiply 33 times the sine of B equals 7 times the sine of 145. Divide both sides by 33. And you get the sine of B equals. So in our calculators, hit 7 sine 145. Make sure you close your parenthesis after that. And then divided by 33. You get like 0.12166. Just hit second sine, second answer. And you guys come out with angle B is about 7 degrees. And that's okay because angle C is so big. So angle B is about 7 degrees. And once we know the angle B is 7 and I know the angle C is 145, how do I figure out what A is? 145 plus 7 is 152. So then 180 minus 152. And I get 28. So angle A is 28 degrees. And now that I know that, I can figure out what side A is. Again, you can use either proportion that you want to. I'm going to go back with one that they gave me at the beginning. So it's sine 145 over 33 equals sine 128. Thanks, Sarah. Sine 28, not 128, over A. Cross multiply, so 33 times the sine of 28 equals A times the sine of 145. Divide both sides by sine 145. So A is about, how long? 33 sine 28 divided by sine 145. About 27? 27.0. Okay, good. These problems are not terribly difficult. They are a little lengthy. You do have to pay attention to what you're doing, but if you notice, it's very redundant. You keep doing the same thing over and over and over again. What you should notice, guys, did we get any negative measures for side lengths or angles? No. You should be able to check to make sure that all 3 of the angles that you find add up to be 180. You should be able to check to see that the side lengths that you find correspond with the angles, meaning the biggest angle should be across from the longest side. The smallest angle should be across from the smallest side. Now tomorrow, because all of these problems that say using law of sines, you have to check for 2 triangles. We're going to work on some of them. They give you information like this, and a second triangle could exist. So we're going to work on that. You will have something like that on your test to make sure. But the rest of this week, we're going to finish up the law of sines. We're going to do law of cosines. But these formulas will be given to you on your test. We have another area problem that we're going to do. Again, those will be given to you on your test because I know this is a lot of information. But good job today, guys.